Hello students, welcome to Vyas Certification Kota. And this series of NCERT discussion will continue further with Mathematics class 12th. The chapter that we're dealing with is integrals, and now is the turn of exercise 7.8. This particular exercise is the point where we begin talking about definite integrals. And this first exercise is actually based on a very important concept called definite integral as the limit of a sum. Now, when we talk about NCERT and when we talk about the board examination, yes, you generally find a question based on this particular topic. But otherwise, when you talk about the competitive exams like JEE Main, JEE Advanced, especially the JEE Advanced people, love asking questions from definite integral as limit of a sum, right? They keep asking such questions, although the level of those questions is way beyond the scope of this particular book, but the concepts are similar and questions are usually asked. Usually asked means they generally ask question every year or every alternate year, that's what you can say, right? They may miss some time, but they generally ask question from this particular topic. This particular topic, that is definite integral as limit of a sum. So here we'll learn the basic concepts related to all of this along with the questions, right? So let's begin with the first question over here. The first question, evaluate the definite integrals as limit of sum, and as you can see, integral a to b x dx is what is given, right? Now, let me tell you the formula first. Let me begin with the formula. What does it say? Formula, yes. The idea of the formula, that's what you can say. Integral a to b fx dx. This integral with a lower limit and upper limit, a and b respectively, is equal to something, some summation. So, this definite integral is equal to some sum. Therefore, definite integral as limit of a sum. What is that sum equal to? So, you have limit n tends to infinity is what we prefer, but it is actually, let me write the version over here, the simpler version, that if you have this kind of area, what is this? This is f of a, this is f of a plus h. If this distance is h and this is a, so f of a is this particular point, f of a plus h is this, f of a plus 2h is this, f of a plus 3h is this, right? And we are looking forward to areas over here. These areas actually, right? So width times height, which is f of a, is what we are looking forward to, and this total will be b minus a has been divided into n divisions, each division having length h. Each division has length h. This is n over here, right? So b minus a upon n is equal to h. Instead of h times f of a, will use b minus a upon n times f of a plus b minus a upon n times f of a plus h, and also and so. So b minus a upon n, I'll write upon n over here, and in the bracket what I'll write is f of a plus h plus f of a plus 2h plus dot dot dot. And what's the last term? Last term will be up till the nth division. If you reach n h plus a, that is equal to b, but you have to give a step back. F of a plus n minus 1 h is what I encounter over here. Yes, this is the bracket. Now, definite integral as limit of a sum. So we have written it as a sum, but limit of a sum simply means that as n becomes very, very large or h becomes very, very small, if the width becomes very, very small, the value of n will tend towards infinity. So this b minus a, if you recall, this b minus a is not dependent on n, right? All of these are actually dependent on n because there's a 1 by n in the product as well. But this b minus a would have been here. This is not dependent on n, so it has been brought out from this limiting value. Right? This is what you have. B minus a is equal into limit n tends to infinity 1 upon n f of a plus h. I've explained the result. I've explained how the result is written, so it will be very, very easy for you to remember this result now. This is a huge result, but it is obtained using that idea over there, right? So once I've written this complete result, what I'll do next is I'll try to solve this one for you. So integral a to b fx, instead of fx we have a x over here, instead of fx we have a x over here. X dx is equal to what? So b and a are simple. This becomes b minus a limit n tends to infinity you have 1 upon n. In the bracket, you have f of a. Now, f of x is x, so f of a will be a. F of a plus h, since f of x is x, f of a plus h will be a plus h plus a plus 2h plus dot 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 dot. Now, how many terms do you think are there over this expression? A plus 0h, a plus 1h, a plus 2h up till n minus 1h. There are a total of n terms, n rectangles and n terms. Similarly, you'll have a plus n minus 1h over here. These are again n terms, and we'll apply the limit after simplifying this expression. So b minus a is okay. Limit n tends to infinity is okay. 1 upon n is also okay. What is this expression equal to? So a. How many times does a occur? A occurs n times. A plus a plus a. Let's separate these out. This occurs n times. Plus, you have another expression. What is that? H plus 2h plus so and so n minus 1 plus h plus 2h plus 3h plus dot 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 plus n minus 1h. This is what you have in the other bracket, in the other term. Right. So b minus a, okay, there's no minus in the front. This is b minus a. Mind you, just the steps look long. They are very easy, by the way. So b minus a by 2. Why are we writing 2 over there? There's no need of that 2. So b minus a is what we are interested in over there. Limit n tends to infinity is what I have. Okay. 1 by n is already there, and in the brackets, what do you have? This is n times a, which becomes na. Plus, if you see, this is h times, you can take out 1 plus h common, and what is remaining is 1 plus 2 plus 3 plus dot 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 up till n minus 1. And the sum of those terms. Let us recall the summation of natural numbers. 1 plus 2 plus 3 plus dot 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 up till n is n times n plus 1 by 2. So if you go up till n minus 1, this n will be replaced with n minus 1. This becomes n minus 1 plus 1, which is n by 2. So it becomes n minus 1 times n by 2. So h times, what you get is n minus 1 times n by 2 in the bracket. This is what you have. And now what next? So this 1 by n can be multiplied inside. We want to apply that limit n tends to infinity, and this looks like 1 n a upon n, which will be simplified, n will get cancelled. This n also gets cancelled with that n. There's an n remaining. Okay, that will create problems. But if we see that there's a h also remaining, and h is equal to b minus a upon n. Yes. So let's replace both of them over there. B minus a times limit n tends to infinity. In the bracket, what do we have? Na upon a becomes a, that 1 by n goes inside, plus h, which is b minus a upon n, times n minus 1. This n and this n will get cancelled. There's a 2 in the denominator. That's what remain. And this n goes over here. This becomes n minus 1 upon n, which is, as n tends to infinity, that will be equal to 1. So this is b minus a, limit n tends to infinity, a plus b minus a by 2 times n minus 1 upon n becomes 1 minus 1 upon n, and now you can replace n by infinity. This becomes a 0, and the overall value will be equal to, therefore overall value, this will be equal to what? I'm writing the overall value over here. This will be further equal to b minus a is there outside. Inside, what do we have? In the bracket, we have a plus this into 1. So b minus a by 2. And what does that simplify into? There's some lack of space over there, but I think we can manage. This is 2a plus b minus a. 2a minus a will be a plus b by 2. This is b minus a, and this is b plus a by 2. This becomes b square minus a square by 2, and yes, that is the required answer over there. Take a look at the steps over there. After this, we have simply simplified this expression over here, and this integral could have been found directly as well. Yes. How could we find that? If you know definite integral, you could have found that directly, that you simply integrate this and you find the limits of that, right? So if you already know definite integral, it will be very easy to verify that that's the answer. But otherwise, these are the steps, and in the next exercise, we'll learn how to use definite integral directly. And then we will be able to verify this, right? This is the solution of this complete question. The important thing is this result, first of all. And once you're okay with that, then it becomes very simple to handle the rest, all the things. Okay, is that okay? Yes. That's the complete solution. Let me get aside so you can take a look at this complete solution again. And that's all that's there in this first question. Question number 2 says,